Good morning, everyone. Today is our second lesson for week 5, and we're going to be talking about percent rate of change again, but this time our objective is to compute the values of these functions. So for our video, we have a do now, definitions, and examples. Then your classwork, again, is a Google form. So for the do now, take a second to try these on your own. The directions are to compute each of the following values for the given exponential functions. So for number 1, f of x equals 2 times 3 to the x at x equals 4. Pause the video, take a second to do those on your own. Okay, so for our first example, if I have x equals 4, I'm going to substitute in, wherever I see an x, I'm going to place a 4. So f of 4 equals 2 times 3 to the 4th. Then I'm going to use my order of operations. Exponents comes before multiplication. So I get 2 times 3 to the 4th is 3, 9, 27, 81, or you could do that in your calculator. And then 2 times 81 is 162. All right, for number 2, f of x equals 54 times 0.8 to the x at x equals 10. I'm substituting in a 10 wherever I see an x. 0.8 to the 10. Now, for this example, I don't know what 0.8 to the 10th is off the top of my head, so I'm going to get out my calculator, and I'm going to say 0.8 to the 10th. And I get 0. So 54 times 0.107. So I multiply this by 54, and my final answer will be 5.798, or if I round to 2 decimal places, that would be 5.8. All right, so the reason we're practicing computing exponential functions is because we're going to be doing exponential functions again today, but specifically the percent rate of change formula. Now, as a quick review from what we did in the last video, this is my percent rate of change formula. Remember, P is my initial value. R is my rate as a decimal, so that percentage always goes to decimal. And T is my time, which could be any amount of time. Hours, minutes, days, years, months. Okay, so let's do a first example. What we're doing initially is going to be the same as what we did in the last lesson, and the new part is just going to be computing a value. So for number 1, the math club at UMBC has a $500 budget for the school year. They want to put the money in a savings account that has an interest rate of 1% per month. Write a formula to model how much money the club will have after each month if they do not spend any money and they keep all the interest in the bank. How much money will they have after 1 year? Okay, so this first part, write a formula, that's what we did in the last lesson. Okay, so let's do that, and then we can find how much money will they have after 1 year. So, they have a $500 budget, so I'm going to circle that, and they have an interest rate of 1% per month. So we know interest will always be growth, right? Will always be growth. So the initial value looks like $500. So P equals 500. My rate, it looks like the percentage is 1%, which means as a decimal that would be 1 over 100 or 0.01. So then I'm going to write my formula. F equals P times 1 plus my R value, all to the T. If I simplify this, I get 500 times 1.01 to the T. Okay, now we want to figure out how much money will they have after 1 year. But what's interesting is the rate is 1% per month. So since we have months here and years here, we need to have a common unit for time. So the time is 1 year, but since the interest rate is per month, I'm going to rewrite 1 year as 12 months. So it's important, you want to make sure you have the same unit in these, okay? So not every time will you have the same unit. Most times you will, but in case you don't, 1 year, we're going to express that as 12 months because the interest rate is per month. Okay, so then if my t is 12, I'm going to have 500 times 1.01 to the 12th. Then I'm going to go to my calculator, and I'm going to have 1.01, and I use my exponent button to the 12th, which is, I get f equals 500 times 1.1268, etc. So I'll multiply that by 500, and I get 563.41. And since this is an amount of money, my final answer is going to be $563.41, or $563.41. Oops, sorry, you couldn't see the bottom. So I've got $563.41. So all we're doing here that's different from yesterday is actually substituting in a t value. We did this, or not yesterday, but the day in the video before, whenever you did it, we already know how to make these equations. Now what we're doing is substituting in a t value, making sure that it's the same unit. All right, I've got 2 more examples for you. Example number 2. The value of a car decreases by about 15% per year. Suppose Daryl buys a new car worth $30,000. Write a formula to model the worth of the car after each year. How much is the car worth after 5 years? Okay, so first we need to write a formula, then we're going to figure out how much is the car worth after 5 years. In order to write a formula, I'm going to circle my rate. I'm also going to circle that this, or underline that this decreases. Okay, that's a key word. It decreases 15% per year. The new car is worth $30,000. Okay, so let's start with my P, my initial value. P, the initial value is $30,000. That's how much he paid for the car. That's how much the car was initially worth. Now the rate, this one's tricky, right? It's 15% is my percentage, but it decreases by 15% per year. So since it says decreases, I'm putting in a negative because we want to show this is going to be going down. So negative 15 divided by 100 will be negative 0.15 for my rate. Okay? Then when I substitute these values into the formula, I have 30,000 times 1 plus negative 0.15 all to the t, or 30,000 times 0.85 to the t. Because 1 plus minus 0.15 is the same thing as 1 minus 0.15, which is 0.85. Okay, now I want to figure out how much is the car worth after 5 years. So I've got 5 and I've got years. Now I'm going to see, okay, the decrease is per year, so my units are good. We're years and years. So I can just substitute in. I'm going to say my t is 5. So F equals 30,000 times 0.85 to the 5th, right? Okay, so I'm going to have to use my calculator to do 0.85 to the 5th, and then I get, I'm going to go over here, F equals 30,000 times 0.4437, so I can multiply this by 30,000. So the value of the car after 5 years is $13,311.16. Okay, so that's a pretty accurate model, right? Every year cars go down in value, so if you buy a car, it is not going to be worth as much as you bought it for in a couple years. All right, if you need any help, make sure you contact me or rewatch the video. We're going to do one more example, and then you'll have your Google classwork, which is very similar, or your Google form for your classwork grade. All right, number 3. The interest on a credit card payment is about 20% per month. Suppose Mary does not pay off her credit card bill of $350. Write a formula to model the amount of money she will owe each month if she does not pay off her credit card. How much money will she owe after 5 months? All right, so I'm going to underline. First, we need to write a formula, and then we need to figure out how much money will she owe after 5 months. And I'm going to circle 20% per month. She starts with $350. This is interest, so we know this is still going to be plus. All right. So my initial value, P, how much money did the bill start off with? $350. The rate, we're saying a 20% interest rate, which will be 20 over 100, or 0.2 is my rate. Then I can substitute these values into my formula. F equals P times 1 plus, and this is positive, 0.2 to the T. When I simplify, I get F equals 350, 1.2 to the T. Okay? Now T, we want to know how much she owes after 5 months. And months, if the interest is also in months, we are good to go. So we have F equals 350 times 1.2 to the 5th. I'm going to do my exponent in my calculator first because that's order of operations. 1.2 to the 5th is 2.488. So I have F equals 350 times 2.488. So I'll multiply this by 350, and I get my final credit card bill after 5 months is $870.91. Okay? So with a 20% interest rate after 5 months, now Mary owes $870.91. Okay? So this is a real life thing, right? So if you have a credit card and you don't pay it off, then your bill just keeps getting bigger and bigger because there's interest if you don't pay your credit card off on time. So if when you get a credit card, always pay your bill on time. All right? Let me know if you have any questions on the Google classwork or about this lesson. My office hours are 11 to 12 every day, or you can text me or comment on any of your assignments. All right, have a good day. Talk to you later.